Yes. Good evening, dear students. Welcome to Sankalp Learning. So today, I'm going to take the chapter that is chemical reactions and equation. So myself, Richa Patil, uh, I'm a lecturer in chemistry. So I'm going to take a topic on chemistry that is chemical reactions and equation. Okay. So should we start the class? Yes. Okay. Thank you. Yes. So what are chemical reactions? Yes, what are chemical reactions? So already in your term you have studied. So just we are brushing up. Okay. So we are going to understand the terms. Okay. What all important concepts are there in this chapter, chemical reactions and equation. So what is the meaning of the word chemical reaction? And before going to the term, uh, can you tell me where we see these chemical reactions? So these chemical reactions, we can observe them or we can see them in commonly in everyday life, right? So in our everyday life, so these chemical reaction occur. So they are common. Okay, they are common. So how we can relate this chemical reaction? How we can understand that the chemical reactions are happening? Okay, so we can see different chemical reaction. How? By some chemical change, maybe by a change in color. Okay, so when a chemical reaction is taking place, there might be a change in color. For example, a leaf. Okay, so there will be, so the leaf is green in color, right? The leaf is green in color. So why the leaf is green in color? Due to the pigment chlorophyll, right? So after some time, the green leaf, it turns yellow. So there is some chemical change, it is occurring. So chemical reactions, okay, how it occurs, okay, by a chemical change. So how it can be seen by different chemical change, okay, like color change, maybe a temperature, okay, temperature change. Okay, you can analyze this chemical reactions. Okay, then if there is a evolution of gas, if the gas bubbles arise, okay, if a reaction is occurring and if a gas is evolved, so there also you can see that there is a chemical reaction occurring. Then it can be by precipitation. Okay, precipitation is nothing but you get a PPT. Okay, you get a substance, insoluble substance, right? So because of precipitation formation also you can say that a chemical reaction is taking place. Now these chemical reactions, they occur in our everyday life. So which are the different processes like digestion? Okay, in digestion, so that is also a chemical reaction. Then while cooking, okay, cooking, for example, you take raw rice. Okay, so what you do, you steam it. So after steaming, it turns into your eatable rice, right? So this also, you can see that there is a chemical change, there is a chemical reaction occurring. So in cooking, then photosynthesis. So photosynthesis is a process where plants prepare their own food, right? So photosynthesis, so this is also a chemical reaction. Then respiration, okay, respiration, human beings, all the living beings, they respire. Okay, they take in oxygen and they give out carbon dioxide. So this is also a chemical reaction which is occurring. Then rusting. Okay, what is rusting? When you have a iron, okay, when you have a iron and it is kept open to the air or the moisture. Okay, so what happens? Rusting of iron takes place. Okay, corrosion happens, the iron get corroded. Okay, so these are some of the chemical reactions which are occurring in our day-to-day life. Okay, now coming to the term, what is a chemical reaction? So what is this chemical reaction? So we have just seen all the different type of processes, okay, which are which we can see in our day-to-day life, right? So here chemical reaction, it is a process, okay, where one or more reactants are converted into one or more products. Okay, for example, okay, if we take a uh, simple this example, suppose we have reactant A and B. Okay, so we have two reactants A and B. So these A and B will react with each other. Okay, so this A and B, they will react with each other to give you C and D. Okay, so these, okay, A and B, they are reacting to give you C and D. So these on the left hand side, what we have written, it is called as the reactants. Okay, it is called as what? It is called as the reactants. And these A and B, when they react with each other to give you C and D. Okay, so on the right hand side, so these are called as the products. So when one or more reactants, they are, okay, they are converted into one or more products. So there what happens, a chemical reaction is taking place. Okay, so A and B are reacting to give you product C and D. So how this chemical reaction occurs? By a chemical change. So you can see some change. Okay, maybe change in state, maybe change in temperature. You can see a evolution of gas, or maybe precipitation formation. So these are some of the chemical change which tells you that the chemical reaction is taking place, okay, because of this chemical change. Now, so as we have discussed, so here is an example, okay. So here on the, so how we write a chemical equation, okay. So this is called as a chemical equation, okay. Now here on the right hand side, on your right hand side, okay, on your left hand side, you have what? There are two reactants. What is the reactant? CH4. What is CH4? Methane. Okay, methane and oxygen. So when methane reacts with dioxygen, okay, so dioxygen, that is a diatomic molecule. Okay, diatomic molecule means when two oxygen atoms combine, you get a diatomic molecule, that is a oxygen, dioxygen, okay, O2. So when methane, it combines with your oxygen, you get carbon dioxide and water as the product. So here is a chemical reaction which is taking place, okay. So on the left hand side, so these are termed as your reactant, okay. And on the right hand side, these are termed as product, okay. How these reactants are product are separated? They are separated by using this arrow mark. So by using this arrow mark, you can see that the reactants are separated, okay. Yes. So like this, we represent the chemical reaction in form of chemical equation. Okay. So on the left hand side, so the reactant, so the substances which are undergoing the chemical change, they are called as the reactant. And whatever the new product, okay, the new substance which is produced on the right hand side, they are called as the product. Okay. I hope the terms chemical reaction, reactants, products are clear. Okay, so moving forward, so this is about the chemical reaction. Okay, now let us see a few examples on chemical reactions. Okay, so there are many chemical reactions, so I have I have taken some few chemical reactions. Okay, so this is the first one. So here you can see on the right hand side, yes. Okay, so they have taken a magnesium ribbon. Okay, we have taken here a magnesium ribbon. Now this magnesium ribbon, what is done? It is taken in the flame. Okay, you can see this is called as the burner. I hope you have seen the burner in your laboratory. Okay, so this is called as the Bunsen burner. Okay, it is called as the Bunsen burner. So in this Bunsen burner, okay, this is used in laboratories. Okay, here what you do, you take a magnesium ribbon. Okay, you take a magnesium ribbon. These magnesium, okay, this magnesium ribbon, what we are going to do, we are going to take a pair of tongs. Okay, pair of tongs is a substance which is used to hold. Okay, which is used to hold. Okay, so here what we are going to do, we are going to take a magnesium ribbon, and we are going to take a pair of tongs. So this pair of tongs, what it is used for? It is used to hold the magnesium ribbon. So by using the pair of tongs, what we are going to do, we are going to hold the magnesium ribbon in the flame, okay, which is produced by the Bunsen burner. So after it is, we are reacting it with the this, okay, what it is going to do, this magnesium ribbon, okay, when it is heated in the flame, it will give you white color flame. You can see here, Yes, you can see here, it is giving a white color flame. Okay, this white color flame, okay, after some time it forms a white powder. So what is happening when the magnesium is holded in this flame? Okay, it reacts with what? It reacts with the oxygen present in the air. So in the air, what is present? Oxygen is present, right? So magnesium, what happens with magnesium? The magnesium, it reacts with the, it reacts with what? It reacts with the oxygen to give you magnesium oxide. Okay, so magnesium. So what you can see? You can see that there is a chemical change taking place. You can see what? You can see a chemical change taking place. How you can see? By what is the change here? What you can see? What is the chemical change? Can anybody tell me what is the chemical change observed? What we have done? We have taken a strip of magnesium ribbon. I have holded it in the flame. Okay, in the flame I have holded it. Now what is what happened when it is when we hold it in the flame? It is giving you white flame. Okay, it is giving you white flame. This white flame later what is happening? It is it is converted into white powder. Okay, that is this magnesium. When it reacts with the oxygen, it gives you what? Magnesium oxide. So what you can observe here, you can observe that there is a change of state. Okay, change of state. So here the magnesium ribbon was first in the solid state, right? It was in the solid. Okay, so here what is happening by the magnesium ribbon was converted into the powder. Okay, so here, so there is a change in color. You can see the change in state. Okay, so this is about your magnesium oxide. Now this equation is not balanced. So further we are going to see the balancing. Okay, so what you are going to do? So 2 MgO2. Okay, so this is the balanced equation. So this is the reaction. So this is the chemical reaction which is occurred when we are burning a magnesium ribbon. So in the atmosphere, air, okay, in air we know oxygen is present. So your magnesium reacts with the oxygen present in the air to give you magnesium oxide. Okay, so here you can see the magnesium oxide. It is what? It is collected in the watch glass. Okay, you can see white color powder. Okay, so this is magnesium oxide. So here also a chemical change is occurring. Okay, chemical change can be observed. Now second reaction. Okay, this is the second reaction. So what is the second chemical reaction? We have taken, okay, two test tubes. I hope you have seen test tubes in your laboratory. Okay, so like this the test tubes will be. So the test tubes will be in different ml. Okay, 5 ml, 10 ml. Okay, so different range test tubes will be there. So what we have done, we have taken two test tubes. What we have done, we have taken two test tubes. So in one test tube, okay, I have taken lead nitrate. Okay, I have taken what? I have taken lead nitrate. So here you can see this is a lead nitrate. Okay, PbNO3 twice. So please see the formula. Okay, please see the chemical formula of the compound. So lead nitrate. Okay, PbNO3 twice. So in one test tube I have taken lead nitrate. In another test tube I have taken potassium iodide. What I have taken? Potassium iodide. Okay, that is Ki. That is what? Ki. So this potassium iodide and lead nitrate solution, you can see these are colorless solution. These are what? These are colorless solution, right? You can see both the solutions are colorless, right? Now here, so here, so both the colorless. Now after adding, so what we have done? So we are taking the lead nitrate and we are adding to the your potassium iodide. So when you add these two mixture, you can see this test tube. It is resulted into a yellow color PPT. Okay, yellow color precipitate. It you can see here in this beaker also. Yellow color precipitate is at the bottom. Okay, yellow color precipitate is at the bottom. So this is what? This is your precipitate. So yellow color. So here this is a chemical change which is occurring. This is what? This is the chemical change which is occurring. Okay. So what is happening? So we have taken what we have taken? We have taken lead nitrate. Okay, lead nitrate is reacted with what? It reacts with the potassium iodide. So what it produces? What it produces? It produces lead iodide. Okay, it produces lead iodide and potassium nitrate. So this is the precipitate of lead iodide. Okay, so yellow color PPT it represents. So I'll write the reaction here. So what you can observe here? So this is a chemical reaction which is occurring. So what you can observe, what is the chemical change observed here? Change in color, right? Change in color. So there is a chemical reaction occurring. So this is the second example of chemical reaction. So let me write the equation. So lead nitrate is PbNO3 twice. Okay. It is reacting with your potassium iodide. Okay. To give you what? To give you your lead iodide. Okay. It gives you lead iodide plus potassium nitrate. So this is the yellow color precipitate which is formed. So yellow PPT. What is PPT? PPT is a insoluble substance. Okay. It is an insoluble substance. Okay. Which will settle down at the bottom. You can see. Okay. So it is an insoluble substance. So this is a chemical reaction. So how this chemical reaction is occurring? By a chemical change. So what is a chemical change which is observed? Change in color. Okay. So this is a second example of your chemical reaction. I hope these two examples are clear. Okay. Previously we have seen what is this. Okay. Chemical reaction. That is the first example was of magnesium ribbon. Okay. Then second was with this two different solutions. Okay. Two different chemical. One was lead nitrate. Then another was potassium iodide. So when we mix these two solutions, we get a yellow precipitate of lead iodide. Okay. So this was the reaction, right? Is it clear? Is this two examples clear? Okay. So shall we move for the next one? So this is the second next example. Okay. So let us go for the next example. Okay. So next example is what? You can see here uh, to your right hand side, there is a conical flask. Right, in your right hand side is a conical flask. In the conical flask, what we have taken? We have taken zinc. Okay, zinc is a metal. Okay, so it will be in the form of granules. Okay, granules means it will be in the like small pieces. Okay, like small pieces. The zinc, your element will be there. So these zinc granules we are taking, okay, in the conical flask, or you can take a test tube also. So I have taken a conical flask. In that, what I have taken? I have taken the zinc granules. Okay, it will be in the form like grains. Like grains, these your zinc granules will be. Okay, now to this zinc, what I have added? I'll add a acid. Okay, I'll add a acid. Either now I'll add H2SO4 acid. What is H2SO4? Sulfuric acid. Okay, what is H2SO4? It is a sulfuric acid, concentrated sulfuric acid. Okay, concentrated sulfuric acid I'm going to add. So the moment when I add, okay, when I add your sulfuric acid, okay, what will happen to the zinc? What will happen to the zinc? The zinc, okay, will react with the sulfate ions. Okay, so this is the reaction which is taking place. So zinc, okay, it reacts with this acid H2SO4 and you're going to get zinc sulfate. Okay, the moment you get zinc sulfate, okay, there will be evolution of bubbles. Evolution of bubbles will be okay, you can see now this. Okay, when you have a, for example, what do you mean by evolution of bubbles? Okay, uh, when you open a soda bottle, okay, you have seen, many might have seen the soda bottle. So when you open the soda bottle, you can see a voice coming. Okay, you can see there is a liberation of gas, right? So that, okay, so what will happen when there is a liberation of gas? What will happen? So that is nothing but your carbon dioxide gas. Okay, in the, when you release the soda bottle, you can see there is a voice. Okay, there is a voice which will come, and that is you can see the gas. Okay, it will move. This carbon dioxide gas will escape out. So that is nothing but, you can say that it is called as the evolution of gas. Okay, it is called as evolution of gas. So like this. So when you, the moment when you add H2SO4 to the zinc, the gas, okay, H2S gas will be, it will evolved out. It will come out. Okay, it will come out with a voice. Okay, so it will release out. And what will happen? There will be, what you can see, that there will be temperature change. Okay, there will be change in temperature. So zinc, when it is separate, and when H2SO4 is there, okay, there won't be any temperature change. The moment when you add H2SO4, the moment when you add H2SO4, what is happening? There will be change in temperature. The flask, if you hold the flask, it will become hot. Okay, it will become hot. So there is a chemical change which is occurring. So what is the chemical change? The chemical change is that there is a evolution of gas. Okay, evolution of gas. So this is the another example of chemical reaction. Okay, so this is another example of chemical reaction. Okay, so we have seen three different chemical reactions, examples of chemical reactions, right? So what did we understand in the, what are chemical reactions? So it is a process where one or more reactants are converted into one or more products. So how this chemical reaction is occurring? By a chemical change. Okay, so these were three different examples of chemical reaction. So next is our chemical equation. Okay, what do you mean by chemical equation? So we have understood the one part of our topic, that is chemical reactions. The next is chemical equations, right? Now, what is the chemical equation? So what you describe, okay, in chemical reaction, what we say, zinc reacted with zinc reacted with concentrated H2SO4, okay, gives you zinc sulfate and hydrogen gas. So this is called as a description. Okay, this is called as description. Now this described format, we are going to express, or we have to write it in the word format. Okay, in the word, this. So that is called as what? Chemical equation. Okay, so description of a chemical reaction can be written in a shorter form. Okay, and that shorter form is called as the word equation. Okay, it is called as the word equation. So magnesium, okay, magnesium, when it reacts with your oxygen, okay, magnesium, when it reacts with your oxygen, it gives you what? Magnesium oxide. Okay, magnesium oxide. So we know that on the left hand side, they are called as what? They are called as the reactants. Right, on the left hand side, the substances, they are called as the reactants. Reactants will react with each other to give you new substance. Okay, okay, and that is called as what? That is called as the product. Okay, and which is on the left hand side, right hand side. So this is on the left hand side, it is called as reactant. On the right hand side, they are called as the product. Right, how the reactants and products are separated? They are separated by a arrow mark. Okay, they are separated by the arrow mark. So whenever we are writing any substances on the left hand side, okay, they are called as what? They are called as the reactant. And how these reactants are separated? Now when we have one reactant, I'll write it as only one name. Okay, and then I will proceed with the arrow, and then I'll write the product. But reactants, okay, when they will react, now when the fight will occur, when two persons are there, right? When two persons are there, then only the fight will occur. So when two persons will fight, then only what will happen? There will be a fight. Similarly, when a chemical reaction is occurring, okay, there should be either two substances or more substances. So here what will happen? A plus B, okay, they will react. So they will react to give you the product C, or maybe C plus D. Okay, now when these two reactants, how we are going to separate them? We are going to separate them with the help of a plus sign. In between, we are going to write a plus sign. Okay, so these are the reactant. Then product, they are written on what? They are written on the right hand side. and how the products are separated. If you have two or more products, how they are going to be separated? They are going to be separated with a plus sign between them. Okay. So, and the arrow, what does this arrow shows? That the reactants are reacting to give you product. They are heading towards the product, and this is the what they are showing. It shows the reaction. Okay, the direction of reaction in which it is occurring. So this is the chemical equation. So this way we are going to represent our chemical equation, okay, in the word form. Fine. So when we write, so this is the reactants, okay, on the left hand side, and products on the right hand side. So this is the, now how we are going to write the chemical equation. Okay, how we are going to write a chemical equation. So chemical equation can be written by using the chemical formula. Okay, how we are going to write? By using the chemical formula. Now here, when we see magnesium, okay, this is a word form. Now I want to write in the word equation, chemical equation form. So magnesium, it is represented by Mg. Okay, magnesium is represented by Mg. And oxygen, okay, oxygen, we are taking dioxygen, that is a diatomic, your diatomic molecule, that is dioxygen. So this dioxygen, what we are going to do? We are going to react. So these are the reactant which we write on the left hand side. This will react to give you what? Magnesium oxide. Okay. Is the reaction balanced? No. Okay. Now on the left hand side, we will calculate the number of atoms, and on the right hand side, we'll calculate the number of, okay, we will, what we'll do? We will uh, find out, count the number of atoms. So Mg on the left hand side, it is 1. Okay. On the right hand side, it is 1. Then oxygen, it is 2, and oxygen is 1. Okay. So we have to balance this chemical equation. Okay. How we are going to balance the chemical equation? Okay. The steps we will see next. Okay. Later. Now here, how we are going to balance? Now oxygen is 2. Here it is 1. So first I will write here 2. Okay, first I will write 2. So now oxygens are balanced. How many they are? Here it is 2. On the right hand side it became 2. Okay. Now we will see magnesium. Now magnesium, again we will check. In left hand side it is 1, and in the right hand side it is 2. Okay. Now again next step is what? We have to balance the magnesium. Now if I write here 2, is it balanced? Yes. So on the both the side, you can see the number of atoms are same. Okay. So this is a balanced chemical equation. So this is a balanced chemical equation. Okay. So we are going to study the balanced chemical equation. Now, you might be knowing the law of conservation of mass, right? What is law of conservation? That is, mass can neither be created nor be destroyed, right? So whenever we are calculating the total mass, okay, whenever we are calculating the total mass of the elements, okay, which is present in the product, it should be equal to the total mass of the elements in the reactant. So whatever the product, so whatever the total mass, okay, is of the product, it is the same as that of the your reactant. So mass can neither be created nor be destroyed. So whenever we are writing a chemical equation, okay, this has to be, we have to use this, okay, that is, the number of atoms on the left hand side and right hand side should be same. The whatever the number of am I audible? Am I audible? Yes, am I audible? Yes. Okay. So let us continue. Okay. Okay. Sorry. So there was some technical issue. Okay. So let us continue. So here, when we are writing the balanced chemical equation, okay, we are going to follow the law of conservation. Okay. That is the total mass. So whenever we are calculating the total mass of the elements, okay, so the total mass of the elements on the right hand side should be equal to the total mass of the elements in the left hand side. So here, when we are seeing, when we are writing the chemical equation, so both the masses should be equal. So whatever the number of atoms are present, okay, they should be same. They should remain same before and after a chemical reaction. So whenever we are writing, so a chemical reaction, it should be in a balanced form. Okay, it should be in a balanced form. So we are going to see the balanced equation. So how to write the balanced equation? Now here you can see the word equation is given of a chemical reaction. A word equation is given. That is, when we say that zinc is reacting with sulfuric acid to give you zinc sulfate plus hydrogen. Okay, how we can represent it? Yes, how we can represent? We can represent. So we write the notations. Okay, for zinc. Okay, how do we represent zinc? Zn. Okay, Zn. Sulfuric acid. What is sulfuric acid? Sulfuric acid is H2SO4. Okay. Then what, when zinc reacts with H2SO4, you get zinc sulfate. Okay. You get what? You get zinc sulfate plus hydrogen gas is evolved. So the number of atoms. So we will see whether the reaction is balanced. Okay. Whether the chemical reaction is balanced. Now here, the number of atom on the left hand side and right hand side. Okay, so zinc is 1. On the right hand side it is 1. Hydrogen, there are 2 hydrogen. In the right hand side there are 2 hydrogen. Sulfur, it is 1. Then your on the right hand side it is 1. Then oxygen, there are 4 oxygen atoms. Here there are 4 oxygen atoms. So this is a balanced chemical equation. So the number of atoms, they are same before and after the chemical reaction. So the total mass, okay, the total mass of these elements, they are equal on the product side as well as in the reactant side, right? Yes. So let us see next is the balancing of chemical equation. So how we are going to balance a chemical equation? So these are the steps. Okay, please read the steps. So what is the first step? First, what we have to do? We have to separate the separate the what each molecule or the formula. Okay, we should not change anything. We should not change anything. What we are going to do is we are going to separate them. Okay, how we are going to separate them? We are going to write, okay, we have to draw a box around each formula. Okay. Second step is that what we are going to do? We are going to list the number of atoms on each element. Okay, either side of the arrow. So you have to see how many number of atoms are present on each side. Okay. Then third step is that from the complete chemical equation, we have compound which is having maximum number of atoms. Okay, we have to select the compound with the maximum number of atoms. Then next step, what is the next step? Next step is that we have to see the number of hydrogen atoms. Okay, we have to see to calculate the hydrogen atoms. Then next step, we have to balance the other atoms. Okay, then lastly, we have to see that each element okay, on both side of the equation should be having same number. Okay, it is they are equal. Okay, and the last step is that you have to write the physical state. Okay, we have to write the physical state of these atoms. Okay, so these are the steps which are involved for balancing a chemical equation. Okay, let us see one example. So this example I have taken from your textbook. Okay, so this is the first equation which I have taken. So iron, okay, iron reacting it with what? It is reacting with water to give you Fe3O4 plus H2. Okay, now what is the first step? Just we have to separate them in, okay, what, how? By writing it in the brackets. Okay, so by writing the brackets around them, so so that they are separated. So this is the first step. So what we are going to do, we are going to separate them, we are going to write them in the separate boxes. Okay, this is the step one. Now second step, okay, second step. So each step is you have to follow the steps. Okay, follow the steps. If for your exams, when they ask you, okay, each step is important. So you should not directly write the balanced equation. So you have to follow each step, because for each step the marks will be given. Okay. Now first step is what? First step, I have to separate them. Okay, and write in the different boxes. Now second, next is what? Next is I will write the number of atoms. Okay, what all atoms are present? Okay, iron, then hydrogen and oxygen. So let me count the number of atoms on left hand side and on the right hand side. So what are the number of atoms on the of iron? Iron here is 1, and on the right hand side it is 3. Hydrogen, hydrogen, here there are 2 hydrogen. Here there are 2 hydrogens. So again, 2 hydrogens on the left hand side, 2 hydrogens on the right hand side. Next is oxygen. So one oxygen atom on the left hand side. Then what is the on the right hand side? There are 4 oxygen atoms. Okay, so this is our second step. So we have seen step 1, then we have seen step 2. Next is our step 3. Okay, next is what? Step 3. Step 3. What is this step 3? We have to select the compound. Okay, we have to select the compound which is having maximum number of atoms. Okay, we are going to select the compound which is having maximum number of compound. Now, which is the compound we have to select here, which is having maximum number of atom? It is this one. Okay, so we are going to select this compound, that is Fe3O4. Okay, now on the left hand side, Fe. Okay, and on the so let me write the complete equation. So Fe plus H2O giving you Fe3O4 plus H2. Okay, now which is the element we are going to see? So H2O converted into Fe2O4. Now let us balance this. Let us balance this. Now here, what I am going to balance? Now I have selected the compound with maximum number of atoms. Next, I am going to see oxygen. Okay, I am going to balance first the oxygen. Now oxygens. Okay, now your number of oxygen atom is 1 and your oxygen is 4. So if I multiply here by 4, okay, if I multiply the water molecule by 4, so here my oxygen atoms will be balanced, right? Is it? It will be balanced. So what I'll do, I will balance by this, okay, or this oxygen by 4. So what it will be? It will be Fe plus 4H2O giving you Fe3O4 plus H2. So what I have done, third step, I have selected, okay, I have selected the compound with the maximum number of atoms. Now here, next step is I am going to balance the oxygen atoms. So how many oxygen atoms are here? On the right hand side, there are 4. On the left hand side, there is 1. So if I want to make it 4, what I'm going to do? I'm going to multiply. I'm going to multiply it with 4. Okay. So Fe plus 4H2O giving you Fe3O4 plus H2. So this is my second step, third step. Next is step number 4. What is step number 4? After balancing the oxygen, I will balance the hydrogen atoms. What I will do? Balance the hydrogen atoms. Okay. So let me write the equation again. So my equation is Fe plus 4H2O giving you Fe3O4 plus H2. Okay. Now here, what I'm going to do? I have to balance the hydrogens. Now see the hydrogens. Where are the hydrogen? Okay. Number of hydrogens here is 8, right? Number of hydrogen, because 4 into 2. 4 into 2 is 8. Here, how many hydrogens are there? 2 hydrogens, right? So here there are 2 hydrogens. So now what I have to do? I have to, so if I want to make this 8, I have to multiply it by what? 2 4s is 8. So I have to multiply it by 4, right? I have to multiply it by 4 to get you 8. So let us write the balanced equation now. What it is? Fe plus 4 H2O giving you Fe3O4 plus 8H2 plus 8H2. Sorry, 8 no, 4H2. Okay, plus 4H2. 4 2 is 8. So now our hydrogens are balanced and our oxygen are balanced. Now next what we have to balance? Step 5. Step 5, balance. Now what we are left with? Balance the iron atoms. Okay, balance the iron atoms. Now let us balance the iron atoms. Iron here on the left hand side is 1 and here iron is 3. So what I have to do? What I have to do next step? Next step is I am going to multiply. What I'm going to do? I'm going to multiply the left hand side with the 3, right? If I multiply it by 3, then the number of iron atoms on both the side will be same. So what is the next step? It is Fe, 3Fe plus 4H2O, okay, giving you Fe3O4 plus 4H2. Okay, this is the our step 5. Okay, now step 6 is what? Step 6 is we have to count the number of atoms. Okay, count the number of atoms here. So Fe again, so count the number of atoms on both the sides. See that they are same: iron, hydrogen, oxygen on LHS and RHS. Okay, so let us calculate now. On the left hand side, Fe is 3. Here it is 3. Hydrogen here is 8. 4 2 is 8. Here it is 8. Then oxygens are 4 oxygen here and 4 oxygen here. So is our equation balanced? Did we complete the chemical reaction? No, right? Still there is major step. What is the major step? Step number 7. Okay, what is the step number 7? We have to write the chemical state. Very, very important. Okay, very, very important. Okay, so what is the next step? We have to write the chemical state. So let me write the chemical equation, that is 3Fe plus 4H2O giving you Fe3O4 plus 4H2. Okay, now here let me write the chemical state. So Fe is present in solid state. S, okay, we write it when we write solid state, it is written in small, okay, brackets, small brackets in S form. Okay, it is solid state. This represents it is in solid state. Okay, then water. Okay, water is in gaseous state. Water, when we write G, means our water, we have used it in the form of steam. Okay, water, it is used in the form of what? It is used in the form of steam. Okay, gaseous state. So water is used in the form of steam. Okay, so we write in the gaseous state. Then Fe3O4. So again, this is solid. Okay, so we write S. Then H2, hydrogen is a gas. We write in the form of G. Okay, so this is your, and L means it is a liquid state. So these are the state, okay, how we represent. Is it clear? Is it clear? This very, very important. Okay, how to balance the chemical equation. One more time, I will repeat it. Okay, So here water is in the form of steam. Okay, when we use water in the form of steam, we use G. Okay, we use gaseous state. Okay, and when we use it in the liquid state, water, then we use L, small l. Okay. Uh, okay. So I'll repeat it once more. Okay, I'll repeat it once more. So these are the important steps. Okay, fine. So let me repeat it once more. Okay. So this is the equation which is given Fe plus H2O giving you Fe3O4 plus H2. Okay. The first step. What was the first step? First, draw the boxes around each formula without changing anything inside the box. So just you have to separate the different molecules. Okay. Writing the boxes, it means we are separating. We are showing that they are different, okay, from each other. Okay, now here, so first one, so these we have written it in the separate boxes. So first step. Second step is what? We have to calculate the number of atoms of each element. Okay, so what we are going to do, we have to see which are the elements present. So which are the element present? Iron is there, hydrogen is there, oxygen is there. Okay, so we have to see on the left hand side and we have to see on the right hand side. So on the left hand side, calculate how many iron atoms are there? 1. Okay. Then on the right hand side, there are 3. Okay. Then on the hydrogen, next is hydrogen atom. So calculate the number of hydrogen atom. It is 2 here. Then here on the right hand side, again it is 2. Oxygen atom element, how many atoms are there? 1 on the left hand side. On the right hand side, there are 4. Okay. So we have listed out the number of atoms in each element. Second step is completed. Third step. Third step is what? We have to select the compound with more atoms. Okay. The compound with more atoms. Now here, the compound with more atom, which it is Fe3O4. Okay. Now this we have selected. After selecting that, what we will do, we will balance the oxygen atoms on both left hand side and right hand side from that compound. Okay. Now here on the water side, okay, on the left hand side, how many atoms of oxygen are there? 1 it is. Okay. On the right hand side, how many oxygen atoms are there? There are 4 oxygen atoms. Now, to make oxygen atoms 4 on the left hand side, what I have to do? I have to multiply it by 4. Okay. So when I multiply the left hand side 1 oxygen by 4, I get 4. Okay. So on the left hand side and on the right hand side, the number of oxygen atoms will be 4. Okay. So what I have done, I have multiplied it by 4. So what I have got here, so what we have got Fe plus 4H2O giving you Fe3O4 plus H2. Okay. Now, next step. Next step is what? Next step, we have to balance the hydrogen atoms. Next step is what? We have to balance the hydrogen atoms. Now, hydrogen atoms on the left hand side, it is 8. Okay. And on the right hand side, it is how many? 2 are there. Now, here it is 8, here it is 2. So to get 8 on the right hand side, what I'm going to do? I'm going to multiply it by 4. So if you multiply 4, okay, by 2, you're going to get how many? It will be 8. So the number of hydrogen atoms on both the sides will be 8. So it is balanced. So let us write it now. Fe plus 4H2O giving you Fe3O4 plus 4H2O. Okay. So we have balanced the hydrogen atoms. Now, hydrogen is balanced, oxygen is balanced. Next is what? We are left with Fe. Okay, we are left with Fe. So let us balance the Fe atoms. Now on the left hand side, we have 1. On the right hand side, we have 3. So on the left hand side, if we want 3, what I'm going to do? I'm going to multiply 1 by 3. Okay, so when I multiply 1 by 3, it will be 3. So let us write the balance equation. 3Fe plus 4H2O giving you Fe3O4 plus 4H2. Okay. Now, so this is the balance equation. Step 6 is what? Count again. Okay. If all the atoms are atoms of the elements are balanced. Okay. Step 6. Step 7 is what you know? Step 7 is you have to write the chemical state. So when you write the chemical state, so you have to mention that this is the balanced equation. So this is balanced chemical equation. Okay. So this is very important. So, okay. So similarly, I'll take one more example. So let us see one more example. I hope it is clear. Okay. So one more example, barium chloride plus aluminium sulfate giving you barium sulfate plus aluminium chloride. Okay. So I've written it in the word equation form, right? Let us write in the equation format. Okay. In the chemical equation format. Barium. Barium, we represented what? Okay. So let me write it here. Step 1. Okay. So step 1. So what is the step 1? First, we will write in the word equation form. So it is barium chloride, BaCl2. How I got barium chloride? Barium is present in Ba plus 2. Okay. And chlorine is minus 1. Right. Barium is plus 2, chlorine is minus 1. They have unequal charges. Okay. Ionic charges. So what I'm going to write? I'm going to write the charge. Okay. Without the sign. So it is what? BaCl2. Okay, BaCl2 like this. Okay, when you want to write the ionic formula, okay, you have to see the ionic charges here. Okay, if they are unequal, what you have to do? You have to crisscross. Okay, you have to crisscross and you are going to write it. It is what? Barium chloride. Now, aluminium sulfate. Aluminium is what? Aluminium is Al plus 3. Right, aluminium is Al plus 3. Sulfate is what? SO4 minus 2. Again, the charges are unequal. The charges are unequal. So what I'm going to write? Write the numbers 3 and this is 2. Okay, what I'm going to do? I'm going to crisscross. I'm going to, now see here, when you have NaCl, okay, NaCl, Na is present in plus 1 state, Cl is present in minus 1 state. So plus 1 minus 1 will cancel and you are going to get NaCl. And you are going to get what? NaCl. Okay, when you have same charges, it will cancel out. But when you have unequal charges, what will happen? Just write the number below that and you are going to crisscross. You have to cross the charges. What you are going to get? I'm going to get Al2 SO4 thrice. Okay. So plus Al2 SO4 thrice. So this is our aluminium sulfate. I hope it is clear. Yes. Okay. Next is what? Barium sulfate. Next is what? Barium sulfate. Barium is Ba plus 2. Sulfate is SO4 minus 2. So plus 2 minus 2 get cancels and it will be BaSO4. So it will be what? It will be BaSO4. So it will be giving you BaSO4 plus aluminium chloride. Aluminium is Al plus 3. Chloride is minus 1. Again, unequal charges. So what it will be? 3. This is 1. So crisscross, I'm going to get AlCl3. So AlCl3. Understood? Is it clear? So first step, write the boxes. Okay, separate the each chemical formula with the box. Okay, fine. Okay, next step is what? Count the number of atoms of each elements. Okay, count the number of atoms of each element. So this is step 1. Step 2, I hope how to write the formulas is clear. Yes, when you have same charge, it will get cancel off. When you have unequal, write the numbers below that and you have to crisscross. Okay, fine. Step 2. What is step 2? Step 2, count the number of atoms. Okay, in left hand side and on the right hand side. So calculate barium, then chlorine, aluminium, sulfur, oxygen. Okay, so there are many atoms here. Barium is 1. On the right hand side, it is 1. Chlorine is 2. Here it is 3. Aluminium is 2. Then here aluminium is 1. Sulfur is 3. Sulfur is 3. Here sulfur is 1. Oxygen is 4 threes are 12 here. Okay, and here it is 4. So this is the number of atoms. Is it clear? Is it clear up to here? Yes. Okay. Next step, step 3. What is step 3? You have to calculate the, you have to see the maximum number of, you have to select the compound with maximum number of atoms, right? You have to select the compound with maximum number of atoms. Now, which is the maximum number of atoms? We can calculate for aluminum sulfate. Okay. So here aluminum sulfate. So let me write it here. Black yellow. So step 3, okay, where aluminum Al2SO4 thrice giving you BaSO4. Okay, now balance the oxygen atoms. Balance the oxygen atom. Your oxygens are how many? 4 threes are 12. Your oxygens are 4. Okay, now if I want to get your 12, okay, if I want to get your 12, what I'm going to do? I have to multiply it by 3. Right? If I want to get 12 oxygen atoms on the right hand side, I'm going to multiply it by 3. So let us write the equation after step 3. It is barium chloride plus Al2SO4 thrice giving you 3 BaSO4 plus AlCl3. Okay. Now, next step is what? After this, I have to balance what? Now, hydrogen atoms are not here. So, let us balance the chlorine atoms. Okay. Let us balance the chlorine atom. So, step 4, balance chlorine atoms. Okay. Let us balance the chlorine atoms. Now here, how many chlorine atoms are here? How many chlorine atoms are present here? So chlorine atoms are 2. Here chlorine atoms are 3. So what I am going to do? If I multiply with a common number, okay, if I multiply it with a common number, now here it is 2, here it is 3. If I multiply this by 3 and if I multiply it by 2, you will get 6, right? So just balance it. So this will be 3 BaCl2 plus Al2SO4 thrice giving you 3 BaSO4 plus 2 AlCl3. Now calculate now the all the atoms. Calculate BaCl, aluminum, sulfur and oxygen atoms. Calculate. Here it is 3. Here it is 3. Chlorine atoms are 2 threes are 6. Here the chlorine atoms are 2 threes are 6. Aluminum are 2. Here aluminum are 2. Sulfur atoms are 3. Here sulfur atoms are 3. Oxygen atoms are 12. Here oxygen atoms are 12. Okay. So our step 5 is also done. Next step is what? We have to write the chemical state. Okay. Let us write the chemical state of this equation. Okay. So the chemical state of this equation, let us write. So the next step. So here only I'll write it. Okay. I'll erase it. So it will be barium chloride, solid, giving you, okay, aluminum sulfate. So these aluminum sulfate, barium sulfate, and aluminum chloride. Okay. So these are the your chemical state. Okay. So after writing this, so this completes your what? This completes your balanced chemical equation. So like this, you have to write the balanced chemical equation. Okay. So take one example for homework. Okay. So this you can solve Sodium plus water giving you sodium hydroxide plus hydrogen. So please balance this. Okay. So we will see this in the next class. Is it clear? Any doubts up to here? So we have seen today what is the chemical reaction. Okay. Today we have seen what is chemical reaction. So what all things we have seen today? We have seen what is chemical reaction, what is called as reactant, what is product. Okay. Different examples based on chemical reactions. Okay. Then we have discussed the chemical equation, how to write an chemical equation. Okay. Then how to balance the chemical equation. We have seen that steps, different steps which are involved and the different examples. Okay. So in the next class, we are going to see the types of chemical reactions. Okay. So yes. Yes. Thank you. I hope you have understood today's session. Okay. So the same topic will be continued in the tomorrow's class. Yes. Thank you. Thank you, dear students. So I'll end the session here. Okay. We'll meet in the next class. Thank you.